quick visit to our architecture. So we've created our model, just a platform model. We're now creating our DB context, which effectively maps our models down to our persistent data store. Now, to begin with, we're just using an in-memory database, but we will move to SQL Server eventually. So this is the next thing that we're going to tackle. So back in our project, new folder in the root, and I'm just going to call this data. I'll put a few data related things in here, and right click and new file, and we'll call this app db context.cs. And then namespace is just platform service.data. And it's just a public class called app db context. And we're going to inherit from the base db context class. And it's probably going to try and autocorrect here, but let's see how we go. Yeah, it did. So just go back and take that back out and just say we're inheriting from db context. So we want to bring in that namespace, so control period, using Microsoft Entity Framework Core. Fantastic. And then we just want to create a constructor that we can, if we need, pass in additional options if and when we need them. So constructor, actually short code for constructor is ctor tab, and then you can just tab through, and we're going to pass in one parameter, which is db context options of type, oh, well, whatever our class happens to be, so db context, and we'll just call that opt, and we can get that from base. Okay, and we don't need to put anything in there just yet, but that's our constructor, our constructor that we use for this. And then most important, well, it's as important, we need to define a database set, or DB set, and which relates to our model. So that's really what's telling our DB context to mediate or mirror our internal model down to the database. So we just specify a property, prop, tab. This time it's of type DB set, and the type of DB set is platform. And we'll complain, so control period, bring in the namespace for our models, and we just want to call that platforms, plural. Okay, so that's our DB context class set up. Then what we need to do is we need to kind of register it over in startup. So let's do that now. And in our configure services method, we want to add that in here. I'm just going to take these comments out because the code looks busy enough at this level of magnification without additional redundant commentary. So yeah, we're going to put that in configure services, which is where we register all our services. No surprises there. So I'm just going to add that here, services, add DB context. What type of DB context are we going to add? Just the class that was added in the last section. And it probably won't find that, so we'll need to bring that namespace in. Control period using platform service data. Fantastic. And then we'll just specify some options. And we're going to tell it what type of database we are wanting to use. We're wanting to use in mem database. And I don't think it's finding this. I think we've probably got to bring back, yeah, using Microsoft Entity Framework Core. Let's bring that back. And let me take a new line on this just so you can see that a bit clearer. And then you just give the database a name. It can be anything, it doesn't really matter. I'm just going to call it in-mem. So we are using our DB context with an in-memory database. And again, we will move to SQL Server, and we'll make some determination in here, a bit of a check to see whether we're using a development environment, which I'll still use the in-memory database, or when we move to production to Kubernetes, then we will use SQL Server. But we can leave that for the moment. We just want to get up and running with our DB context. And that's it for our DB context. So in the next section, what we're going to come on to doing is we are actually going to work with a repository. So we're going to start to set that up in the next section. And really what I want to try and do is get all this blue stuff kind of set up, this data stuff set up before we move on to the more interesting stuff. Not that this isn't interesting, but we get all this wired up and then we can move forward. So repository next. All right, so back over in our project, what I'm going to do is I'm just going to get rid of this terminal for the moment. Gives us a bit more space in our on our screen. And yeah, we're going to create a repository now, and we're going to use the interface concrete class pattern because we will inject our repository through dependency injection in our startup class. But if you don't quite follow that, don't worry, we'll do it step by step anyway. So the first thing we want to do in our data folder, yet again, is create an interface. And an interface basically just specifies what type of things, the method signatures effectively, that our repository will support, and then any concrete class can come along and implement those interfaces. So yes, over in our data folder, right click, new file, and because we're defining our interface first, we will specify a capital I, and I'm just going to call this platform. There we go. You're just going to do it eventually, platform repo for repository.cs, not repi. That sounds like it's Latin, and I did it again, repo. All right, I platform repo.cs, okay. And namespace of platform service and data, and it's just a public interface called I platform repo. And then all we do in here is specify this method signatures effectively. So the first one, and if you've done any entity framework core stuff before, you'll realize what this one is for, but basically we need to save any changes that we make. So whenever we add stuff to our DB through our DB context, adding it or deleting it is not enough. You actually have to save those changes. So we'll need to put something like that in here, which is what that is. And you'll see how that works when we come on to doing the concrete class. And then the first kind of proper signature that I want to define is getting all our platforms. We want to be able to use our API, use our service to retrieve all platforms. So specify it as an enumerable, which we don't have the namespace for. So enumerable of platform, a platform class, or platform service. And we'll just call that get all platforms. And we're not going to pass anything in. So quite a simple operation. So bring in using system collections generic for the IEnumerable, and then we'll bring in the, try that one more time. Using platform service models, there we go. Okay, so this interface should allow us to get all platforms, specifying it as an IEnumerable. Next one we want to do is just return an individual platform. So not an enumerable this time, just returning a platform, and we'll call this get platform by ID. And this time we will pass something in, which will be the identifier of the platform, the ID of the platform, the unique ID. And then the last one is we want to be able to create a platform. So we'll just make that void, call it create platform, and we will pass in a platform object into that method. And then we'll have to call save as well when we come on to doing that. But that's basically our interface done. These are the three, or really four, but these are the three things that this interface should provide somebody that is choosing to use this interface. And now what we need to do is we need to build out an implementation class of this interface. So we'll do that now. So again, in data, right click, new file, and we'll just call this platform repo.cs. So over here in namespace, create namespace, and call platform service, data, fantastic. And then we just specify it's a public class called platform repo, and it's going to implement iPlatform repo there. Okay, and straight away it will complain because we've not actually implemented any of these methods here. So again, our best friend, put your cursor in there, control and period, and click implement interface. Now it's not clever enough to actually fully implement it. All it does is create these placeholder method definitions, and then you can just see it's just throwing a not implemented exception. So yeah, it doesn't fully implement it, but yeah, it gives us the placeholders that we need, which is good enough. And actually you wouldn't want it to implement it anyway, because generated code is not that great, but this is fine. All right, now before we come on to doing that though, we want to actually create a class constructor, and this is our first use of our first proper use of seeing how dependency injection works. So again, ctor to create a shell constructor, and what it's going to expect to be injected in is an instance of app db context, and we'll just call that context. Okay, so whenever we use platform repo via our interface, when it gets constructed, it's going to expect an appdb context to get passed in. And because we have registered our appdb context here in our configure services method, that will occur. Okay, so I'm not going to go too much more about that. I would expect you to be somewhat familiar with dependency injection, so I'm not going to explain it further than that. But we'll use it so much throughout the rest of this course that it will definitely become second nature to you. And then to finalize, we actually need to make use of this context that's injected in. So we do that via a private field. And the convention is to typically start these with an underscore. Well, I do anyway, and you'll see it used a lot like that. So basically, whatever's injected in here will get assigned to this. And again, this doesn't exist, so control period. And what you want is this one here, generate read-only field. And I'll put it up here for us, private read-only appdb context. And you'll see this pattern used time and time and time and time and time again throughout the rest of this course. And that's really dependency injection in a nutshell. So we can come on to working with our methods down here. So I'm going to start with the simplest one, and we'll do save changes. So let's just get rid of that for the moment. And all we want to do is return, and we're going to make use of our db context. And we're going to say save changes on that context. And then this little bit here is really just saying if the result of save changes is greater than 0, then we basically return true back. So we had something that changed. So that's all that is. And we'll call this after any create, update, or delete operation. Any unsafe operation that we have on our data source, we will have to call that to make sure those changes are flushed down to our database. All right, so let's start with this next one, which is getting all platforms. We'll do that one next. And it's really quite simple. Return, again, we'll make use of our injected context. And then on this, you can see that we have our platforms object available, and that is just coming from, that's just this property here. We're just referring to that now. So we're going to return platforms to list. And I think we'll probably have to bring in the link namespace here. Yep, so control period using system link, it puts that in at the top for us, fantastic. And that's all we need to do for that. We'll come on and do our get platforms by ID, and it's slightly more complex, but not much so. So return context, platforms, but this time we're going to use this first or default method to say, give us the first instance of a platform or the default one. And then we're going to specify some criteria using a lambda expression. So we'll say P goes to P, and we're wanting to find the ID of the platform where it's equal to, I'll get rid of that prompt, where it's equal to the ID that we pass in. So quite straightforward. We're basically saying, yeah, return everything from platforms, what the first or default item, from platforms where the platform ID equals the ID that we passed in. So it's conceivable that we get nothing. It's conceivable we get a null return there, but nonetheless, that's okay. And then finally, well, we've done that one already. And then the final one is creating a platform. So first thing we want to do is check to see that we've had some sort of valid object passed in. So we'll just do a fairly simple if plat equals null. Then we don't want to do anything. So actually I probably shouldn't have deleted that throw statement, but we'll just type it in again, throw new argument. Actually puts a slightly different exception, argument null exception, name of plat. Okay, so that just gives us a more descriptive exception, and we'll just bring in that namespace using system. So if platform is null, if it's not been defined and we're trying to create one, then we'll just throw this exception. Otherwise, Quite straightforward. Context, platforms, add, and then we just add the platform object that we've been passed in. Fantastic. Now when we come to use this, as I've said before, we'll then need to call save changes to flush that down to the database. And that's it. That's it for our repository, and that's actually it. We're not going to change this now. That's our finalized repository, and that's our finalized AppDB context. So the next thing that I want to do, and just before we do our DTOs, is kind of create a little class that's going to prepare our database. So when our app starts up, I want to actually put some data, some mock data into our database, just so that we have some there to work with. And when we come on to using SQL Server, I want to also run what's called migrations to actually create the data structure in the database. With the in-memory database, you don't actually need to run migrations, which is kind of good, but kind of bad. The other thing I will say about the in-memory database that we're using now is that it really is only used for test purposes. It's not a production type database. And of course, because it's in memory, if the service restarts, you'll lose all your data. So it's really, can't stress it enough, probably should have mentioned it when we were setting up our DB context, it's really just for, it's really not even used much in development environments. It's really just used for testing, really. But we're making use of it here just because it's going to get us up and running much quicker than setting up databases. So we will eventually move to SQL Server though. So yes, anyway, what we want to do next is prepare our database, put some data into it. So we're going to create another little class to do that, and then we'll come on and finish off with our DTOs before we move on to writing up our controller. All right, now actually just before we go on with creating our database preparation, one thing I forgot to do, having created our repository interface and our concrete instance of a repository, one thing I didn't do was actually come over and register that for dependency injection, so that when somebody asks for an interface, a repository interface, we give them whatever concrete class we specify. So the way we do that is just over in Configure Services, and we'll just make use of services again, and we're going to add a scoped service, and we will just say if somebody asks for iPlatform repo, we're going to give them platform repo. Cool. So yes, obviously very important when it comes to using dependency injection, we register our interface and the concrete implementation of it in Configure Services. So somebody asks for this, we give them this. Fantastic. So let's just save that off. The one thing we've not done so far is build. So let's just bring up our command line and let's just do a .NET build. There's not much to run yet, so we'll just do a build. I mean, it should be okay. We'll run it once we've kind of come to the end of this sort of section of data stuff. So that's all good. So I just want to do that, make sure we're okay to go. So yes, next what we're going to move on to is creating a class to kind of prepare a database with some example data. Okay, so just back over in our project, I'll just close down our startup class and give us a bit more space. And yes, we're going to create our database preparation class. So over in data, just right click, new file, and we're going to call this prepdb.cs. And then we'll begin with a namespace as usual, platform service.data. And this is a public static class with the name of prepdb. Get that round the right way. And yeah, static class, we don't need to create instances of it. And this class is going to have two methods, one public and one private. And the public method is going to set up a database context for us that we can use. Now, this isn't a constructor, this is just a public method. So you might be going, wait a minute, got a couple of questions here. Why aren't we using constructor dependency injection? Great question. Well, we can't because it's a static class, so we can't use constructor dependency injection. And the second question you might have is, why are we using a DB context? Why don't we use the repository that we just created? And that's another great question. So the reason I'm using a DB context in this case is that eventually I'm wanting to use this class to generate migrations in our SQL Server database. And it's just much easier to do that directly on a DB context. All right, and there's a couple of other methods that we're going to use here that I don't really want to build into my repository anyway. This class here is really more for testing. This is not something I would probably push into production. It's really just for us and for this video to help us set up things in our database environment. So that's the two reasons. We can't use constructor dependency injection, and I'm using a DB context mainly because I want to use it eventually to create some migrations. All right. So with that being said, let's create our first, let's create the signature for our first public method. So it's public static void, and I'm going to call this prep population. Now, before we define what we're going to pass into it, if we come over to our startup class, we're going to call this method, this prep population method, on this class from startup. So once we've run configure services and then configure starts to get run, we're going to call it in and around here. And what we're going to pass in order for us to be able to use a DB context is this application builder instance here. We're actually going to pass this through into it, and then we're going to use this to create something called a service scope, which we can then use to create a DB context. So it's a little bit heavy at this stage in the course, and it's slightly off topic, but we have to do it, and I'm just trying to explain it as best I can. So hopefully you'll follow the code. It's not that bad. But let's get on with it. So yeah, we need to pass in an instance of this to this method over here. So let me just code that up now. So application builder, and we won't have the namespace for this obviously, and we'll just call that app. So what I'll do is I'll just bring in the namespace for that, and I think I probably spelled it wrong. Yeah, there we go. Application builder. Let's try that again. There we go, using Microsoft ASP.NET Core Builder. So that's a good tip. You know, if you're doing the control period thing and you don't really see what you want, chances are you've spelt whatever it is wrong. Okay, fantastic. Now, just before we continue with this, what I'm going to do is I'm going to pop over to our startup class, and I'm going to just call this method because we've got everything we need now that startup needs in order to know about it, and call it, just so I don't forget. So PrepDB, we can access the class directly because it's a static class, and then prep population, and we're just going to pass over app. All right, and that's all we need to do in our startup class, so I'm going to save that off. So back over into PrepDB, we will carry on with this. So yeah, as I was saying, we need to create like a service scope in order to derive a DB context. So I'm going to do that via a using statement. So I'm going to create, first of all, a variable called service scope. I'll make that equal to using our app, application services, and then create scope, which I don't think will be available to me just yet, so I'll have to bring in that namespace. So control period, that's the one we want. Microsoft extensions, dependency injection. Fantastic. Now in here, we're actually going to call our next method, our private method, which is the method that's going to do all the seeding of our data and eventually run our migrations. So let's just create the method signature for that. It's a private static void method called seed data. And this is going to expect an app DB context. And we'll just call that context. Okay. Fantastic. So where is seed data going to get an app DB context from? Typically, if this was a normal class, it would be via constructor dependency injection. You can't do that, as I've said, so we're going to have to create an instance or call this method, this private method, with an instance of app DB context from within our first method. So let's do that now. So let's call seed data, and then let's give it the DB context it so desperately desires. And we do that by making reference to the service scope we've just created upstairs, using service provider, and then get service. And any ideas what service we want to get? Of course, AppDB context is what we want to push in there. And don't forget the round brackets at the end. We can close that off with a semicolon. So this public method, that's it, it's basically complete. So now, for the remainder of this little section, we're just going to fill out the seed data method that we're going to use to, in this instance, just pass in some data. As we're still using the in-memory database, we don't need to worry about migrations. We just need to pass in some data. We will come back and update this though when we move to SQL Server. All right, fantastic. So let's move into here. Just, make sure I'm indented in the right place. So the first thing I want to check to see if we have any data in our database relating to platforms at all. So we'll make use of our context, and we will just look at our platforms instance, and that's, if you come back over to AppDB context, we're just referencing this here basically. And then we can use this, probably have to bring in link here, but we can use this any syntax to see. There we go, we're getting autocorrect because we don't have link reference, so let's do that now using system link. Yep. So if the context platforms has anything or doesn't have anything, so make sure you put in the exclamation mark, so it's a not operator. If we don't have anything, then we want to push data in. Okay, otherwise you do nothing. Now I'm just putting this else statement in really just to help us with a bit of output, a bit of debugging output. So I'm going to do a console, and I'll bring in the system namespace, so control period using system, console write line, and I'm just going to say we already have data. And that'll come in useful when we actually use SQL Server and data will be persisted. At the moment, most of the time, we're always going to be seeding data at startup because we're using in memory. And if once we shut something down and restart it, all the data's gone anyway. So for the moment, we're never going to see this. We're only going to see that when we move to using SQL Server, but we'll put it in for the moment. And then likewise up here, I'm just going to put in a console write line, and we'll just say something like seeding data, ... just so we know it's kind of working. All right, so now we'll come on to actually putting some data in, and there's another nice method we can call on our platforms object, on our context, so we'll use that now. So context, platforms, and then we can use this method called add range, and it's quite nice because it allows you to add a number of objects at once, which is quite nice. All right, so we're going to create a few new platform objects to pass in and create. And remember, DB context works off of the model, the platform model, nothing to do with DTOs. This is all internal to our platform. So new platform, I'm just going to bring in the namespace. I think I brought in the, used the fully distinguished path, which I don't like. I'd rather bring the namespace in up at the top. So we're going to create, yes, a new platform, and then we simply just specify a new platform. So name equals, first one, let's do .NET, why not? Put a space in there. We'll specify the publisher, which in this case would be Microsoft. And we will then specify the kind of rather ambiguous cost attribute. I'll just say it's free. All right, now I want to create a few more. Now, rather than watching me type those out, I'll just go over to my notes, and I'm just going to copy in a couple more. And you can, of course, put in as many as you like here. You don't just need to put in 3 like I'm doing. There we go. In fact, let me get rid of this thing at the side. So Control B to take away the panel gives us a bit more space. So nothing too controversial. We're just creating a couple other platforms, SQL Server Express and Kubernetes. Don't forget the commas at the end of each line, except for the last one. All right, so that's cool. We've added our products to the database effectively. Do not forget, and I always forget this, do not forget to context save changes. Because yes, that add range will add stuff to the database, but unless you save the changes, it's not going to go in there. So that's it for the moment. I think that's it for the moment anyway. PrepDB is done. It's going to start up, give us a database context, and add that to our database. So why don't we give that a go now? We did add the call to this method here in startup, so it should be good to go. So Control / to get a command line up. Let's do .NET build, just to build it first. Although when you run it, it builds it, but I like to do the build before the run. I don't know why. .NET run now. So what we should see is this seeding data message. There we go. I think it flashed up on screen. Quite quick though. Yeah, seeding data. So cool. It's realized we don't have any data in our in-memory database, and it's seeded the data. Now we can't do anything with that now. We can't access it yet. That's when we come on to our controller. Fantastic. But what we're going to move on to now, just to kind of round out the data section, is look at DTOs. We're going to create some DTOs. We'll do that next. All right, so back over in our application, I'm just going to kill our running server, Control-C, and get rid of this terminal. So yeah, we're going to come on now to DTOs. Now, before we start coding, just a little bit of a sense check by reviewing our architecture. So we've created our model, our platform model. We created our DB context. We have an in-memory database. We will move to SQL Server at some point, and we spent some time creating a repository, which our other classes are going to make heavy use of. But just to round out this kind of section, we're going to now move on to DTOs, data transfer objects. And what are data transfer objects? They're basically external representations of our internal models. And you might be going, why do you want to do that? Well, you don't want to expose your internal models to external consumers. Why not? Well, number one, there might be data in your internal models that you don't want to expose, right? The other thing, which is possibly what's as important, is that as soon as you expose your internal models to external consumers via an API, for example, straight away you're creating a contract with them. And if you then want to start changing your internal models, which is entirely conceivable, and you should be able to do that, you may break the contract with your consumers. And you're basically tying your internal implementation to an external contract, which you absolutely do not want to do. So you need to abstract away your internal data from your external data. And that's all DTOs are. Okay, so they're very valuable, and that's what we're going to do next. All right, so back over in our application, make sure you've closed down any running services or anything like that, any running servers. And I'm going to do Control B to bring back up our directory explorer. And I'm just going to close down these windows here just to make it a bit nicer. And we are going to create yet another folder. So right click, new folder, and we're going to call this DTOs. I'm going to hit our first DTO, new file, and I'm going to call this platform read DTO.cs. Now you might question this and go, what? Don't we just create one DTO? You could, but you're not really going to get the maximum benefit from them. We're going to create quite a few DTOs. In this section, just 2. So the use case is consumers are going to be reading data from us, platform data from our service. So this DTO, the read DTO, is going to be a representation of any data that we want to provide in that context when anybody's reading from us. The other scenario is going to be when somebody wants to create a platform using our service. We're going to provide a view of the data that we expect to be given in that scenario. And it's going to be very slightly different, okay? And that's where the real power of DTOs come in. Anyway, let's get on with this one first. So namespace, platform service, DTOs. And it's just a public class called platform read DTO. It's a very, very, very simple class. And I'm just double checking I'm spelling platform correctly. That looks good. Now what I'm going to do, I'm going to come over to our models folder, into platform, and I'm just going to copy all of our properties. I'm going to paste them in here. Okay. Now I don't mind doing copying and pasting in this instance because I've already typed this code out, and I'm sure you don't want to see me double writing it out again. So let's take a look at these properties. And think to ourselves, when somebody is reading data from us, is it conceivable that we would want to give them the ID of our platform object? Yes, we absolutely would. Would we want to give them the name? Yes, we would. Would we want to give them the publisher? This is where it starts going into, well, it depends what the intention of our API is. In this case, we're going to give it to them. And then cost, the reason I put this property in is really to kind of make the point that this could really be an internal bit of data that we don't ever want to expose. So again, if you didn't want to expose that, you would take it out. But for now, I'm just going to leave it in. May take it out later. We'll see how we go. So for the moment, our read DTO is going to be exactly the same as our platform DTO, and that's fine. But what it does mean is that you can change your internal platform model later, and this could remain exactly the same. Fantastic. All right, so that's all looking good. So we're going to create another DTO now. A little bit more interesting, new file. I'm going to call this platform create DTO.cs. Platform create DTO.cs. All right, great. So start with the namespace as usual. Platform service, DTOs. It's a public class called platform create, sometimes even too fast for my capabilities here, platform create DTO. All right, fantastic. Now what I'm going to do, I'm going to come back over here and I'm just going to copy this again. But this time, let's think about the data that we've got here. So someone's going to create, this is for when somebody's going to, this is specifying the data we want when somebody's going to create a platform with us. The first property here, the ID, do we want them to give us the ID? No, in this case we don't, because we take care of that. Our database takes care of that by creating a primary key for us, and that's where the unique key comes from. So when someone's creating a platform with us, we do not want them to supply the ID as part of the body payload, so we take that out, okay? As for the other stuff, we'll leave that in, okay? Because we do want it. Now, let me just pop back over to the platform read DTO, and I actually took out the data annotations there. I should have mentioned that because it's a read DTO, I don't really feel that we need the data annotations in this case, so I'm just taking them out. For the platform create DTO though, I'm going to leave them in because out the box .NET does some nice data validation stuff with our controller actions. So if somebody doesn't supply one of these properties when they call our controller, .NET will go back with a nice pre-formatted error condition for us, which is really nice. So that's why I'm going to leave it in this case. So in order to use them, control period, and we'll bring in this namespace. All right, and that should clear up our errors, and we'll save that off. So yeah, platform read DTO, it's got all the properties. I'm just going to take out this double spacing, it's kind of annoying me. We've got all the properties that we had in our platform model. We're not using data annotations, but that's okay. And then our platform create, slightly different shape to it. We don't require the ID, but we are using data annotations. Fantastic. So that's our 2 DTOs done for this point in time. Now, at this stage, we've got our model, our platform model, and we have our 2 DTOs, but they're just separate classes. They don't know about each other. There's no way we can map at this point to them, but that's what we're going to do next. And we're going to use a tool called AutoMapper to allow us to map from one to the other. So we'll do that next. All right, so moving on to AutoMapper now, let's just clear down our development environment. And there's a few bits of setup required for AutoMapper. The first thing we should have already done, so over in your CSproj file, just double check that you have this package reference included at the top for AutoMapper. And if not, please add it, otherwise the next bit's not going to work. The next thing we need to do is register AutoMapper for dependency injection. So over in Startup, in our configure services method, we're going to do that here. So making use of our services collection once again, there we are, add AutoMapper at the top. And yeah, that should become a relatively familiar pattern that we're using. You can see it's complaining here because we do actually need to provide a little bit of extra detail inside the parentheses. So add domain, app domain, my apologies, current domain, and then get assemblies, and don't forget the parenthesis at the end there, and we'll save that off. So that's AutoMapper now registered in a dependency injection container, so we can use it throughout the rest of our application. Now the final bit of this section is to create what's called a profile. So again, we've got our DTOs, we've got our models, they are not in any way mapped together, and we do that via a profile. So in the root of our project, right click, new folder, we're going to create a folder called profiles. And into that, we're going to create a single class called platforms profile. So new file, platforms profile.cs. Okay. And then the usual setup, the namespace of platform service, and this time it's profile. Profiles plural, and curly brackets, and then it's just a regular old class, so public class platforms profile. And we're going to inherit from an AutoMapper class called profile. Okay, now this has tripped me up a few times. Our folder is called profiles, our namespace is profiles plural, this class is profile singular. Okay, it's tripped me up a few times and caused me a few issues, so just make sure you get that correct and bring in the right namespace using AutoMapper. Fantastic, so that's our shell of our class setup. Now, where we create our mappings is actually in the class constructor. So just CTOR to do the shortcut for platforms profile, and tab across, and we just take out the parameters. We don't need any in there. So this is our class constructor, and it's in here that we create our mappings. So let's create our first map, and I'll talk you through about exactly what is happening. And before I do that, let me just do a little annotation, source to target. All right, so we use something called create map, and we specify the source. So think about a scenario where somebody is using our service to read data, consume data from us. Ultimately, that data, the source of it, is in our database. It becomes a model. Well, it is a model, a platform model. That's the source object, and we're going to then map that model to a platform read DTO and give the consumer the read DTO. So the source is the model, platform model, and the target is the read DTO. And that's what the mapping is. Now again, if this is a little bit abstract, when we come on to writing our controller, it will become a lot more obvious when we actually start putting it into practice. But for now, let's create our mapping. So platform, so this is our model, is the source. And let me just bring in the namespace for that before it starts, autocorrect starts driving me mad. So using platform service models, and then our target is platform read DTO. Close off the angular brackets and end with a parenthesis and a semicolon, and we'll just bring in that namespace. So again, just to reiterate, this is servicing our reading scenario. So the source of our data is our platform model, and the target is our platform read DTO. Now, a couple of important points here. Because our platform class and our platform read DTO have properties that are named exactly the same thing, and that's the way we want to map them, we don't need to tell AutoMapper anything else. Hence the name AutoMapper, it does it for us, which is brilliant. When we move through the course, we're going to be creating other classes and other entities where that's not straightforward, and we have to then explicitly tell AutoMapper how to map or not to map between properties, but we don't need to do that yet. The second point is here that we've created a mapping with a source of a platform model to a target of a platform read DTO. Brilliant. If you then had another scenario where you needed the source to be a platform read DTO and the target to be a platform, you have to explicitly add that here. Just because we've created a mapping one way from those two objects doesn't mean that there's an implicit mapping the other way. You've got to explicitly add that, okay? Just those 2 points are pretty important. So just before we finish off, we'll create our last mapping, and this one is for the creation scenario. So again, in this instance, the source of the data is a platform create DTO, because that is what our consumers are giving to us. That is the source of the data, and the target for that ultimately is going to be the creation of a model down in our database, a platform model in our database. So the source is a platform create DTO, and the target is a platform model. Okay, so create map once again, and our source this time is a platform create DTO, and the target is a platform model. Make sure we get that correct. All right, and that's it for now. We will add more mappings in here with some rules as well, actually, but for now, that's all we need to service our current scenarios. So save that off, and the last thing I want to do, just before we move on to working with controllers, is just do a bit of a .NET run, just to make sure everything's running up and building okay. And if it is, we can move on to the next section. And it looks good, so let's move on to controllers. All right, so moving on to our controller now, I'm just going to stop our server from running. I'm going to kill the running terminal. And as usual, I'm going to clear down our previous work that we're doing just to make it look a little bit cleaner. All right, so we already have a controllers folder from when we scaffolded up the application, so we obviously don't need to create that, but right click on that, new file, and we're going to create a file called platforms controller.cs. It's obviously a CS file. Fantastic. And then as usual, we define the namespace of platform service controllers. And then it's just a public class called platforms controller. We're actually going to inherit from something called controller base, which is really a base controller class that's really used for APIs as opposed to full-blown MVC web applications. so controller base. And we will have to bring in namespace, so control period, Microsoft ASP.NET Core MVC controller base. Oh, I selected the wrong option there. I want to, oh, I did it again. Get it right this time. Using, here we go. My eyes were a bit crossed there. Oh, there we go. So we add the using statement at the top, that's what we want. Otherwise it's going to get way too busy. All right, so we're going to create a constructor, so ctor, tab, and into this we are going to work with our repository, and we're going to eventually work with AutoMapper. So let's get going with that. So the first thing we're going to inject in is our platform repository. So what are we asking for? We're asking for an I platform repo. I'll just check that's what we called it. I know we just created it not so long ago, but I just want to make sure, yeah, I'm giving it the right name. So we're creating one of these, and that will be injected in. And we'll just call that repository. And then we're also going to request an instance of mapper, iMapper, which is our AutoMapper stuff, and we'll just call that mapper. And we'll need to bring in the namespaces for both of these. So using AutoMapper and using, I think I might have, yep, there we are, spelt it wrong, platform, not platform, there we go. So try that again, that's better. Okay. Now, as usual, what we want to do is we're being in, these two parameters are being injected. We want to assign them to private fields, usually denoted by an underscore. So we'll assign repository to underscore repository. There we go. And likewise for mapper. And we'll use these private fields inside our class. And of course, they don't exist yet, so control period, and we want to generate a read-only field for each of them. And you can see they are added at the top here. Now, this is the kind of very, very standard constructor dependency injection pattern that you're going to see lots and lots throughout this course. Constructor for a class will pass in a number of parameters, and then we'll assign them to private fields, private read-only fields that we then use within that class. Fantastic. Now, the other thing we want to do is we want to actually decorate our class with a couple of attributes. The first one is API controller, and that gives us a lot of out-the-box functionality relating to API controllers, and I'll call those out as and when we come on to them, but it's mainly around passing through data via our actions and stuff like that, and yeah, sort of default behaviors that most web APIs will want to adhere to. So it saves us a bit of work. And then we want to also define our route, okay? And this is basically where we can find this API and then subsequent actions. So square brackets, route, open round brackets, and we're going to specify API / and then you can either specify explicitly the name of your controller, so for example platforms, or you can use this kind of wildcard approach where you can just put in square brackets controller, and that will take this portion of the controller's name, everything aside from the word controller, and basically put it in here. So you get the same result. So this route to this controller will be API / platforms. Okay, up to you which way you want to do it. I've seen it being used both ways, either using this way or just actually hard coding it, up to you. All right, fantastic. So now we want to come on to our first action, and in doing this first action, we can actually then test to see whether everything we've done so far has actually worked. So we're going to do an action that just gets all the platforms that have been added to our backend database. So public action result, it's of type IEnumerable. And we're going to have to bring in that namespace, and it's an enumeration of, what is it? Enumeration of platform read TTOs. Okay, and let me just finish this method signature, and I'll just take you through exactly what we're doing here, just in case it doesn't make sense. And we'll call it get platforms. Okay, so we're not passing anything in, we're not passing in an ID in or anything like that. And yeah, that looks okay. And we're going to decorate it with a verb HTTP get. There we go. So let's save that off. Now, I think this, I'm surprised, I think I've made a mistake here. Let me just put this other bracket in and then I'll probably get some complaints. Just finish that off. I'm surprised it's not, there we go, it's not complaining, it's complaining now thankfully about the fact that we didn't have IEnumerable or platform read DTO namespaces at the top. So let's bring those in. So control period, systems collections generic, and then platform read DTO. There we go. So basically what this is saying is when you call this action, and it's going to be get action at this route, API platforms, we're going to return an enumeration of our platform read DTO. Not our platform entity, not our platform model, but our platform read DTO, because we've said previously, whenever we're sending data out, we want to send over the DTO, the read DTO representation of our data. So that's why we're doing that. And then from there, it's actually relatively simple. And we're going to get to a point where we're almost ready to actually see that we've not made any mistakes throughout this whole build process to date. So just to help me debug if it's, you know, if we have any issues, I'm just going to put in a console write line. I have to bring in the system namespace, so control period using system. And I'm just going to say getting platforms. And hopefully we get some platforms, but we will see. All right. So we want to now make use of our repository to actually go into a repository and pull back the platforms that we want. So I'm going to create a variable that will contain the return result set from our repository method. So platform items, and this is going to be an enumeration of platform models that our repository turns back. So we'll make that equal to, and we'll make use of our repository, and then we'll have a look, and we want to get all platforms. And we'll just do that. So that will go into our repository class. Let's come over here. It's going to use this get all platforms signature here, and then in our concrete implementation, it reaches in to our DB context and returns us a list of platform objects. Okay, so we have platform objects in here, but we want to return platform read DTOs. So this is where AutoMapper comes in. We're going to map our models to our read DTOs and return that back. And that might sound rather complex, but it's not really, thanks to AutoMapper. So we're just going to do a return. Okay, so HTTP 200 result, and then we're going to make use of mapper, our injected mapper object. So it's mapper, map, and what are we going to map to? We're going to map to an IEnumerable of what? Let me just see if I can get rid of this thing, it's a bit annoying. An IEnumerable of platform read DTOs. There we go. And what are we mapping from? So this is what we're mapping to. We're going to map to an enumeration of platform read DTOs. What are we mapping from? We're going to map from this collection here of models. All right, and that should be enough to basically get us at the result that we want. So if we just come back to our profiles and we have a look in here, basically that is going to be making use of this mapping construct here. Now, even though we're using an enumeration, doesn't matter, it's smart enough to know that enumeration or single objects, it will still work okay. So again, AutoMapper, very, very cool thing. So let's save that off. Let's do a control backtick and let's do a .NET run. And hopefully everything should be wired up correctly. I don't think I need to do anything with the platforms control. If we come back over, before we test this, we come back over to the startup class. Let me just move this down. Our controllers have already been added into configure services anyway, so everything should be